Okay, students, the important info for 10.4 is on inscribed angles. If you have an inscribed angle, that's when the vertex is on the circle, like these three examples. The relationship between the inscribed angle and the arc that it intercepts, so the arc between where the angle sides are, the angle is half of the arc. Okay, the other formula that was in this section is when you have a tangent. A tangent, remember, is a line or segment that touches the circle at only one point on the outside of the circle. And a chord, remember, has endpoints on the circle. When they intersect, the measure of the angle formed by the tangent and the chord is half the measure of its intercepted arc. So in this example, this angle here is equal to half of the arc its sides intersect. So the same formula for both types of angles, where the angle is equal to half the arc. Okay. The other important facts that we learned in this chapter are that if inscribed angles, so like this angle here and this angle here, intercept the same arc, they both intersect this arc right here. Their endpoints are on the endpoints of the arc. These angles are congruent to each other. The other, another important fact is that if the inscribed angle happens to have endpoints on a diameter, which means it's in the semicircle, because I could draw in my diameter here, then the triangle formed is a right triangle, because that would make it a 90-degree angle. If you have a quadrilateral inscribed, meaning the vertices of the quadrilateral are all on the circle, the opposite angles are supplementary. Remember, supplementary means they add up to 180. So in this diagram, R plus T would equal 180, and S plus U would equal 180. All right, so let's look at the practice that goes along with that. So number one says, given that angle B is 28 degrees, what is the measure of arc AC? So angle B is 28 degrees. AC is the arc it intercepts. So we said the angle is equal to half the arc. So 28 is equal to half of X, what we don't know. So you could multiply both sides by 2. That would cancel out this fraction, and we would get that 56 is equal to X. So AC would equal 56 degrees. Number 2, given that AC is 66 degrees, what is the measure of angle B? So this is working backwards. We said that the angle is equal to half the arc. So we don't know the angle, but we do know the arc. So in this case, we would just multiply half of 66 to get that it is 33 degrees. Number 3, we've got 2 questions. We're saying that what is the measure of arc AEB, this major arc, if DB is tangent and ABD is 32. So ABD is 32. So this is an example of a chord and a tangent. We know this angle, so we're trying to find out AB and AEB. So AB, we can use that 32 to help us find AB, because AB is the part that's intercepted by the tangent and the chord. So same formula, angle is equal to half the arc. So 32 is half of something. Multiply both sides by 2, so 64 is X. So in this case, our X out here was AB. So the measure of AB is 64 degrees. That answers this question. We still need to find AEB. Arc AEB would make up the rest of the circle. Since a circle has 360 degrees total, we would subtract the amount we know to get the remainder of the circle. So if I take 360 minus 32, I'll have 328. So the measure of arc AEB is going to be 320. Oops, I'm sorry. We have to take away 64. Scratch that. 296. All right, that's 10-4. Oh, we got a couple more for 10-4. All right, so we talked about how an angle inscribed in a semicircle is going to be a right angle. So I know this angle is going to be a right angle. This arc out here is 80. This angle is intercepting that arc. So this angle would be half of that arc. So this angle would be 40 degrees. We know that a triangle has to add up to 180. So if I have 90 and 40 already, that's 130. So 180 minus 130 would give me x. So 50 degrees is x, right? That's one way we could have figured it out. There's other ways you could have gone about doing that problem too. In this problem, it says circle F, GH is 70. What is the value of x? Now the triangle is there, but in this case, we don't really need the triangle, okay? Because this is just our inscribed angle. So we know that the angle is equal to half the arc. So x is going to be half of 70, which is going to give us 35. Okay, so it didn't really matter in that case. If we wanted to then go ahead and figure out what this angle was, like if we called this y, we know this has to be a right angle. We could figure out that angle by adding up what we know, the 90 and the 35, and taking it away from 180, right? So 90 and 35 would give us 125. If we took that away from 180, we'd be left with 55 for y, okay? Number 6, the quadrilateral is inscribed in the circle. What's the value of w? So the important thing here is that you remember the opposite angles are the ones that are supplementary. So opposite of w is going to be 115. So if I say 115 plus w has to equal 180 because the opposite angles are supplementary, I would just take the 115 away from the 180. So I'm going to get 65 for W. All right, 10-5, your last section. We had a lot of information in this section. We had information about angles, and we had information about segment lengths. So we learned that the angles that are created by intersecting chords, there was a special relationship that the angle was equal to half the sum of the arcs that were intercepted. So these are the arcs we're talking about, and those are the angles that we're talking about. Okay. We learned about tangents and secants, and secants, or tangents and tangents. They all have the same formula. Okay, the angle formed by those pieces is equal to half the difference. So this was half the sum, this was half the difference. Okay, if the angle you're looking for is on the inside, right, with the chords, we're doing half the sum of the arc. If the angle is on the outside, like in these three situations, we're doing half of the difference of the intercepted arcs. The length of the segments, when you have chords get split into two parts. This is like part 1, and this is like part 2. We multiply the two parts of the chords together, and then they're equal to part 1 times part 2 of the other chord. So you multiply the two parts together and set them equal. When you have a secant and a secant, this is where you do the whole secant. So that's this whole thing times just the part on the outside, so the exterior. Okay, and the exterior is just this part here. Okay, and it's equal to the whole times the exterior of the other one. So the exterior of this one times the whole. Okay. So anytime you have a secant that and you're finding the lengths, you're going to use that part. Just like on this formula, we have a secant, so we're using this whole thing times the exterior, which in this case is just t, is equal to, and then when you have a tangent, it's just the exterior because there's no interior of the tangent times itself. So it means exterior squared. So in that case, it's this part right here. So we just say the exterior squared, or your teacher might have called it the tangent squared. Okay. All right, so let's apply those questions. And I see that this, I'm going to have to fix this on your worksheet. What is the value of m got moved? So number one here, what is the value of m? Okay. So what is the value of m? We have secant and secant, and we're looking at angles. So this is going to be the angle is equal to half the difference of the intercepted arcs. So I'm going to say in this case, my angle is m. M is equal to half of 130 minus 40. So half of 90, which will give me 45 degrees. Right, number two, I'm looking at angles. Okay, so if I'm looking at angles and I have two tangents, I'm going to use angle is equal to half the difference. Now, I know that this is 220 degrees from here all the way around here. It's like I have three missing pieces because I don't know the angle and I don't know this other arc, but I can figure out the other arc. Because if this makes up a whole circle, to get this other piece here, I just need to subtract 220 from 360. So if I say 360 minus 220, it's going to give me 140. So that's my other arc. So I can fill in everything in my formula now. X is equal to half of 220 minus 140. Okay, so I'll do my subtraction first. And I get half of 80. So X is equal to 40 degrees. All right, QR is a tangent to the given circle. The measure of SR is 96 and the measure of PR is 162. What is the measure of angle PQR? So I'm looking for this angle here. So I'm gonna put my X there. All right, I've got a tangent and I've got a secant and I'm working with angles. So I'm gonna say angle is half the difference. And I'm going to plug in 1/2 of 162 minus 96. Is 66. So I'm doing 1/2 of 66, which is 33 degrees. Okay, number 4, what is the value of m? I'm going to say the angle is equal to half the difference. I'm going to multiply both sides by 2 so that my fraction cancels out. So I have 64 is equal to 122 minus m. I subtract the 122 from both sides. and I get negative 58 is equal to negative m. Then I divide by negative 1 to get that m is 58 degrees. Okay, in the diagram below, and now I see that when I printed this out, it got cut off at the bottom, but we've got all the information we need. So it's a circle. This would just continue down here with 2 chords, and we're looking for this missing piece. We're looking for AE. So I'm going to put my X here. On your papers, this would be at the top of the next column. All right, so we're going to do part 1 times part 2 is equal to part 1 times part 2. So I'm going to have 10 times x, because those parts belong to this chord, and 8 times 5. So 10x is equal to 40, so x is equal to 4. All right, for number 6, we are looking at a secant and another secant. It says, what is the length of ED? So I'm going to put my x there. So for secants, we do exterior. Your formula said whole times exterior equals the whole times the exterior. So this whole thing is 14. This exterior is 5. This whole thing would be 7 plus x. This exterior is 7. So on this side, I'll take care of the 14 times 5. And over here, I'm going to have to distribute that 7. So I get 49 plus 7x. I subtract the 49 from both sides, and then I divide by 7. So my x is going to be 3, which it stood for my ED, so I answered that question. All right, the next one, I've got a tangent and a secant. So this is where I use the whole times the exterior is equal to the tangent squared. I'm looking for FE, so that's going to be my x. So for my secant, the whole thing is 16. The exterior is 4. For the tangent, I'm going to write x squared. So I've got 16 times 4, which is 64. So my x would be 8 after I take the square root. Now, we did not do a problem like this, so I'm going to add this onto your papers. So you will have this question. Okay. And if we need to find x, since we have 2 chords, and this is going to end up being number 8 on your papers. We have 2 chords, and we're trying to find this angle. The formula is going to be that the angle is equal to half the sum. So x would equal half of 64 plus 52. So half of 116. So our angle would equal 58 degrees.